Hola, soy Enrique Cuan Urquizo, profesor de la materia Diseño y desarrollo de máquinas, y a continuación les presentaremos algunos proyectos finales del semestre agosto-diciembre 2020. El proyecto tenía como objetivo exponer a los alumnos a las tendencias en el diseño mecánico, como Generative Design y Topology Optimization. Ambas han cobrado auge con el reciente crecimiento del uso de la manufactura aditiva en la industria.
My name is Ana Paulina Alvarez, and in behalf of my team, I am going to present our project. Planetary gear trains are commonly used in car transmissions because they allow you to change your car ratio without having to engage or disengage a clutch. The application we are going to design is for velocity reduction. In order to reduce velocity, the gear of the output must have more teeth than the gear from the input. Therefore, we decided the number of teeth with the following formula, which means that the ring equals 2 times the planets plus the sun. Now we're going to present a simulation. As it can be seen, the light gray gears are the planet gears, the blue one is the sun gear, and the external one is the ring gear. The ring gear must stay stationary, and the input is in the shaft from the sun gear, and the output in the carrier, which is in green. In order to be able to analyze safety factor and to choose the bearings, we made the following force diagrams. Some of the forces are either canceled out or zero, having the final resultant diagram from the right one. Here we can see the failure analysis in SolidWorks from the shaft. The left one is the von Mises stress, and the red part is because we had to add a tiny part to be able to simulate the torque, the input torque. And the right one is the safety factor. We got a 3.37 safety factor, which is reliable because it's greater than 1. And the material we use is a steel IEC 1045 because this is commonly used for gears and shafts. Here is the failure analysis of the planet gears with a safety factor of 2.20 from the simulations. It is a little bit different than the one calculated because this contains both bending and contact, and we also used IEC 1045. For choosing the bearings, we used ball bearings from SKF, and we chose one that was able to support this 54.6 load. We translated the pounds to kilonewtons, having a resultant value of 0.24 something. Therefore, we chose one with 0.52 kilonewtons to have a greater life. And in here, we added a frame to our planetary gear train to be able to later add this whole assembly to the frame of the transmission of the car, as it can be shown in these front and back figures. And here we put one with transparent frame, so it can be seen how the planetary gear train is implemented. Commonly, car transmissions have more than one planetary gear train, but in this project, we only designed one. So for future stages, we could design the other two planetary gear trains. And after having the forces, we could make a generative design. This is very useful for reducing the mass of the elements and improving the efficiency of the system. We made the one of the input shaft, of the planet gears, and of the carrier. From the carrier, we can conclude that the edges were not necessary. And in the planet gear, SolidWorks showed a design with no contact between the center and the teeth of the gears. Therefore, we propose a star design because the element is going to be rotating. And in here, we implemented the generative gears to our planetary gears, so the planetary gear train. So this would be our final system, which would be later implemented in the car transmission. We can conclude that all the elements must have a security factor greater than 1 in order to be reliable, and the system that we designed would be functional if physically implemented. We would only need to design the other two planetary gear.
Now we will present our final project. At the beginning, the system that was used in the car requires a lot of force from the passenger, so it was quite difficult to make any kind of movement. That was until Francis W. Davis developed the power-assisted steering system. Ooh. Now we will show you our mechanism. First, we have the basic mechanism that contains the gear train, then the motor that assists the driver when turning the steering wheel by acting on the ring gear. Then we have the driver that transmits the power using the sun gear. And finally, the car that moves the pinion with the moves of the mechanism. And now we'll show you a video of the mechanism working. Ooh. Nice. Now I will begin by showing you the analysis of the gear train. Here we have a table with all the characteristics for every gear, every single gear, with all the forces that were exerted in them, with the two inputs that was the motor and the sun gears, and its output that was the carrier. Now we have the stress analysis that we have the boundary conditions with the bending and stress analysis with its resultant forces. This is the bending for the inner and outer teeth of the ring gear. Now we have the contact express boundary conditions with it loading. The contact express simulation. And a video. Nice. Now we have here a table with all the safety factors for the planetary gear analysis. The lower was 22 for the bending and the highest was 98. And for the contact, the lower was 88 and the highest was 672. Now we have the shaft analysis. This is the free body diagram for the two use shafts. And here we have the failure prediction for the static and the fatigue in both of the shafts. This is our steering mechanism that was built by using two crankshafts by moving them with a rack and a pinion. Here's our kinematic analysis that was done using MATLAB and Solid. This is our kinetics analysis that was done using MATLAB to find the maximum forces exerted in the joints. And in the image, it shows the boundary conditions. Here we have this safety factor for the static analysis, and is this the simulation for the deformation of the static analysis. This was our bearing selection. We wanted to make sure that every joint in every lane had a bearing. First, we have the sun shaft bearings, then the shaft bearings, and finally the mechanisms joints bearings. Generative design. In our generative design, we put 5 mechanisms and 4 supports, 2 shafts, a carrier and a steering wheel,